Hey guys, I'm Pat Kelly. Okay, in this problem, the directions really just tell us to evaluate this integral here. And there's a part A and a part B, where for each part, they're really just giving us a different r of t vector, okay? And we'll do the work for each of those. And I think the directions also ask us to explain how the orientation of the curve affects your answer. So we will end up comparing these two answers. I'll talk about that. But before I actually begin, I think I'm going to do a quick rewrite that's going to be helpful for us. Is this integral that they want us to find, I'm sure you've seen before, that this equals the integral from a to b of that f vector when we express it as a function of t, dotted with the r vector but primed, a derivative there also of t. And then it's a dt integral, an integral with respect to t. The significance of that for me here then is that this version of it's going to be very easy to kind of slip into for these problems because my r is already in terms of t. I'll have to get my f in terms of t, which we've done before, and I'm also going to need my derivative, which is ancient news, right? So let's dig in. I know I'm going to need that derivative, and my r vector is right here, so I think I'll just right away do an r prime of t. So that equals 2 times the I vector, plus the derivative here is just 1, so j vector, and I'm good. I also want to see what my capital F function, or vector function, looks like here. My f of t equals. It's trying to say that, yeah, you've done these before, you've seen this before. What we do is you go to your r function and you take this component, the 2t in this case, the component of the I vector, that's your x. So plug that in here. I have to square it. So I get 4t squared times I. And then plus, which is coming from my f function, x times y, so I'm multiplying these two different components, so 2t times that t minus 1. Times that j vector. Okay. All right, that's my f. That's my r prime. That's why I wanted this formula in front of us, because now I'm just going to dot product, set up my integral. So this integral from a to b, my a is 1 and my b is 3. It's going to be your limits of the t value. And then dot product here, dot product, make sure I look in the right one, is r prime with the f vector. So I multiply these components, 8t squared plus, and then I multiply the 1 times the 2t times t minus 1, which is just going to look like that. Okay, and all of that is dt. And this is looking pretty friendly to me now then, so let's go ahead and integrate. I think actually as I integrate this, I think I can distribute in my head here, because this is 2t squared when I push it through, and there's already a t squared, so I'm looking at 10t squared. That'll become 10t cubed over 3 when I integrate. And all I'm left with is whatever I didn't distribute through already. So the 2t times the minus 1 is minus 2t, and that anti-differentiates to just a nice t squared. That's good. And I do have limits of integration here from 1 to 3. Okay, let's plug some values in here. I'll give you a heads up too, as I might end up resorting to a calculator for some of these computations, so you can grab one as well. 3 cubed, 27, but cut that down by 3, so 9. That's looking like a 90 minus 9. Subtracting what happens when I plug in a 1, that's going to be 10/3. Minus a minus will be plus 1. And see, I didn't want to have to resort to doing that arithmetic in my head, looking for that common denominator and whatnot. So you can, if you want, you know, for fun. But I'm going to go ahead and put in here 90 minus 9 minus 10 thirds plus 1. I don't like decimals so much. It's a fraction. I'm looking at 236 over 3. Okay. All right. That's my answer for the first half of the problem. Second half of the problem is actually just a different path, the C sub 2. I'm going to grab a different color for you as well. But it's the same work, so I'm going to begin, like I did over here, is with my r prime vector that I need. Differentiate this. The derivative here inside is just a minus 1, so minus 2 times the I vector. And then plus the derivative in here actually is also just a minus 1 times the j vector. Okay, and then that's my r prime. I also want to have my f vector in front of me and ready to go. Like I did before then, I've got to look back at the original f here, but my x's and y's are coming from the x component, the I component here, and the j component there for the y. So I'm following this. I see x squared, so I have to square this. And I get 4, I'll put parentheses, 3 minus t, parentheses squared, and that's times the I. Plus, the plus actually comes from here, and then x times y, so I'm going to multiply this times that, and I'm looking at 2 parentheses, 3 minus t times 2 minus t, and that's all times your j vector there, right? Okay, I think I have my players ready to go. Here is r prime and also f, because I'm now going to try to get into my integral and do dot products there. So my integral, this time going from 0 to 2 for my a and my b, 0 and 2. Let's just do some dot products as we go here. Multiplying, I'm going to have a minus 2 times this component, so a minus 8 times that 3 minus t squared. We're still doing a dot product, so plus, I just said plus, but it's a minus times this, so let's just say minus 2 times that 3 minus t, and then 2 minus t. And all of that, I want to make sure I get this grouped well, is dt. Okay. All right, so it's long. We're actually going to maybe simplify it a little bit, but it's definitely a very doable integral here. So let's go ahead and rewrite this 0 to 2. And I don't want to take too many jumps here. If I go ahead and FOIL this out, looking at 9 minus 6t plus t squared. Let's keep that minus 2 out in front for another step or so. FOIL these out. I'm looking at 6 minus 3 minus 2 is minus 5t plus t squared. And all of that actually is still dt multiplied by the dt. So, all right, we're in better shape now to clean this up. I don't know if I'm still not quite ready to anti-differentiate, because I would like to combine some like terms, make this easier on me. Minus 8t squareds minus 2t squareds looks like minus 10t squareds. Okay, my t terms are going to be a plus 48, and then also plus 10, plus 58t. And then my constant terms, a negative 72, subtract 12, negative 84. And that's all still inside my integral here. Okay, keep that calculator handy too here. We're going to do some plugging and chugging in a minute. Just one more calculus step, I guess, is my antiderivatives. Minus 10 thirds t cubed plus, this will be t squared over 2, so let's call that 29t squared. then minus 84t. And I still have to evaluate all of that from, what were the numbers, 0 and 2. Oh, I'm glad there's a 0 in there. Now if I just put my 2 in, I'm looking at minus 80 thirds plus 2 squared is 4, so that's actually what, 80. And now let me do, I'm going to a calculator anyway, so what the heck, why don't we just do that, and I'll put that in the calculator, minus, feel a little guilty though, I'll do that one in my head, 168, if I double correctly, but I'm going to grab a calculator now. So now I'm looking at minus 80 over 3 plus 29 times the 4, because I was lazy, minus 168 equals, I'm looking at a decimal again, fraction equivalent is negative 236 over 3. Which, hey, you know what? That sounds familiar. Let's take a step back. We're done with the problem, A and B, but the answers A and B are equal but opposite. So the directions did say something about how to, they want you to explain how the orientation of the curve did affect your answer. So we're seeing the same answer here but opposite, and that's because, looking for another color maybe even to grab, these two paths are actually the same, just in reverse direction. If you actually plug in, let's do a plug-in of the 1 for t, you can see your coordinates are going to be 2, 0. And we're traveling to where the t is a 3. If I plug in a 3, I'm getting 6, 2. All right, so what? Now come over here and do the same. Plug in a 0 here, and I'm getting 2 times 3 is 6, 2, and we're traveling to, when we plug in the value of 2, 3 minus 2 is 1, multiplied by the 2, and then 0. So you're hitting both of those same points, but in opposite order, opposite direction, and that's why our answers here are exactly opposites. Okay? All right, go do some on your own.